Okay, so today we are starting our module 7, which is dynamic routing protocol. So in dynamic routing protocol, we have three section of protocols, which is RIP, EIGRP, and OSPF. Okay, and these are the topics what we will be covering in this session. Okay, this is a separate RIP session, separate EIGRP, and separate OSPF session. Okay, now. So same thing like as we have completed static and default, in that also we came to know what is routing. See, routing is what? Routing is a process of forwarding the packet from one network to another network. Routing is used to create communication between different unreachable network also. Means when you have two different unreachable networks, and in that unreachable networks, if you want to create communication, so communications will be done only when you have configured routing. Now routing is also used for selecting best path. It's not that you configure routing and communication will be there. No, routing has also process of best path communication. Like if you have multiple routers connected here, see, this is your router, and when you are connected to some two different ISPs, okay, and when you are connected with two different ISPs, so in that I should follow this path or I should follow this path. Okay, so these decisions are also taken by this routing protocol. Okay, and the best route will be kept in the routing table. Here we have types of routing, like we have routing, two types of routing: IGP, interior gateway protocol, and exterior gateway protocol. And here the interior gateway protocols are divided into two sections: static and default. And then we have dynamic. So static we have already completed, default we have already completed. Now we have to work on dynamic. So in dynamic we have distance vector, hybrid routing, and link state. Distance is your RIP and RIP version 2. Hybrid is means the combination of link state and distance vector, that is known as hybrid routing protocol. So EIGRP is hybrid, which use both routing protocol, your distance vector algorithm also, and link state algorithm also. Okay, so here what I was saying that the routing protocols are divided into multiple
Hello?
sections,
Um,
and uh, in those sections
okay.
the IGP is used for internal in organizations communication. Like whenever you want to use some kind of protocol inside your organization, you have to use IGP, interior gateway protocol, and EGP is used to communicate between two ISPs or two enterprise networks or two autonomous system networks. Okay, but here we have to work with this. Okay, so
Okay.
static we have already know, it's a manual routing. Default is just for internet communication, but dynamic is the main routing protocol which is used in the organizations. Okay, so now we
Yeah.
have to work with RIP first, then EIGRP and OSPF. Okay,
Okay.
okay, so remember what I told you here, that dynamic is used
Yeah.
by organizations nowadays. Statics are also used. Okay, but for large
Okay.
enterprise organizations network, dynamic is best. Okay, default is, oh, see, all type of routings are in use. Okay, but depending on your
Yeah.
condition, depending on your organization, you have to use all type of routing. Okay, so we will start from RIP first.
Yeah.
In types of routing we have static routing, default routing, dynamic, and
Yes.
we have already completed a static, we have already completed default, and then we are working in dynamic routing. Dynamic routing is automatic negotiation routing between neighbors. Okay, automatic data exchanging between neighbors when the protocols are running same between neighbors. Okay, Now,
Okay.
so we already know about dynamic routing. That dynamic routing is also known as adaptive routing, and it is a technique in that or in that technology you can say router adds a new route in the routing table for each destination network. Okay, but same like a RIP, sorry,
Yeah.
same like a static, but in this dynamic, okay, these things are automatic, not manual. Okay, dynamic protocols are used to discover the new routes to reach uh, the destination networks. In dynamic, we have three different type of protocol: RIP, EIGRP, and OSPF. And I already told you that it is a automatic adjustment between neighbor if there is any topology change. Dynamic protocol should have the following features. Okay, means if I want to exchange data with you, so we must have same dynamic routing protocols running in the routers. Okay,
Yes.
now dynamic routing protocols table is created, maintained, and updated by routing protocols running on the routers. But in a static, we configure everything manually. Okay. Now examples of routing protocols are
Mm.
RIP, EIGRP, and OSPF. Now in dynamic routing protocol, when they work with some, like when the router works with dynamic routing protocol, okay, so CPU, RAM, and bandwidth utilizations are there because they exchange some kind of messages between neighbors. But static do not negotiate and do not send message between neighbors to talk, okay, frequently. But in dynamic routing protocols, they always send hello message, different type of message depending on the packet type. Okay, that's why they
Yes.
utilize your
Yes.
bandwidth utilization of the link, and there will be CPU utilization, RAM utilizations also. Now dynamic routing protocols are capable of dynamically choosing a different or better path. Okay, so dynamic routing protocols are good to find better path if you have multiple path.
Yes.
Dynamic routing protocols, they share the like routing table with the neighbor. Okay, locally connected networks, and behalf of that they build routing table and they decide which one is best. Advantage is that it is easier to configure, it is faster. Okay, and in the dynamic routing protocol, if the primary path is down, automatically it switch over to the alternate path and it start communicating with those neighbors. Okay, now it is more
Okay.
effective in
Yeah.
selecting
Yeah.
the best route in response of topology change. Okay, disadvantage is what that disadvantage is that it is more expensive in term of CPU and bandwidth uses. Okay, and it is less secure as compared to the default and like default I'm saying as per static routing. Okay, so it is less secure. So dynamic is less secure as compared to a static, but if it is less secure, we have some other options to secure those routing protocols with the help of authentication mechanism. Okay, now so we already know the dynamic has three category: link state, sorry, distance vector, link state, and hybrid. Distance vector is your RIP, link state is your OSPF, and hybrid is EIGRP. So first we will learn about RIP. IGRP is not in use, it is okay, RIP. Then we will learn about EIGRP, and then we will learn about OSPF. So this is your RIP routing information protocol. Okay, so RIP stands for routing information protocol. Okay, now so what is RIP? Okay, so RIP is a standard distance vector protocol. Standard means this RIP protocol can be used on any router. Okay, means or any vendor router you can say. Means it can be used by Juniper. It means you can use this routing protocol on Juniper router, on Cyberon router, on D-Link router, okay, MikroTik router, any routers. Okay, now RIP can be used for small organizations only, not for large organization, because it can only support 15 hops, means you can say 15 gateways. Okay, now RIP use UDP protocol port number 520, okay, as a transport protocol for sending the updates to its neighbor. Okay, and RIP can supports only up to 4 equal load balancing to communicate with neighbor. It cannot support multiple neighborships. Okay, so limitation is 4, but you can increase up to 16 and up to 32 depending on your iOS, what iOS you are using on your router. Okay, so the for older iOS routers you can support only 32, sorry 16, but for the newer one we can support up to 32. Okay,
I've now
so
connected it with the people themselves. Yeah.
okay, now RIP sends out the full routing table, okay, in every 30 seconds, means every time. It's a periodic message, so whenever RIP wants to communicate to its neighbor sending hello message, so that message will be sent to neighbor in every 30 seconds periodically. Okay,
Okay.
now RIP use administrative distance, okay, is one kind of number given to each and every routing protocols to determine who is best. Okay, that is the number tag, you can say. With that, which one is the best, they will come to know. Okay, now RIP routing protocol share its locally connected networks to its neighbor. Okay, and after that they make routing table. Okay, and then in that routing table they decide which one is the best path. Okay, now here we have RIP version. Normally when we work on RIP, okay, so RIP has two version. Okay, version 1 and version 2. But when the RIP came in the networking, okay, or when the RIP has been advertised, okay, or announced as a open standard, so at that time RIP version 1 was there, and it was supporting only class full routing protocols. Okay, but nowadays uh, when we work with the network we have classless routings. Okay, classless network. So when you want to use RIP in a classless network, so we have to use RIP version 2. Okay, RIP version 1 use one broadcast address for communication between neighbors, so they communicate with the neighbor with the help of this broadcast IP, which is 255.255.255.255. Okay, but in RIP version 2 it use multicast address to 24009. Okay, and RIP 1 do not support authentication, RIP 2 supports authentication. Okay, now when we are talking about the configuration of RIP. Okay, so RIP 1 configuration is like that, and then RIP 2 configuration is like this. Okay, so we'll see while configuration how it is working. Okay, so this is our RIP 1 lab. Okay, so we have to design and work on this lab.
Got out of right?
Yes, yes. No, now we are working with RIP lab.
Okay.
Okay, so in RIP lab we can take
Okay. Okay. With it.
any type of router. This is OSPF lab, so let me open RIP lab.
Okay.
RIP RIP lab 1. Okay, so let me explain you this lab first. That here we are using 3 router. Okay,
Okay.
and if you want we can connect one more link also from this side to this side, Ethernet 0 on.
Yes.
Okay, for redundancy. Okay, and here we can use one network which is 13.1.1.0/40. Start all the labs.
Um,
Okay.
Mr. J,
Yes.
why do you connect router 3 and router 1 and router 3 with an Ethernet cable, while the router connecting to router 2 is with serial?
Yes. See, when you want to connect router to router, you can use any link, Ethernet link or serial.
Okay,
Serial can support only 1.5 Mbps. Okay,
okay,
and
yes,
default cost of Ethernet is 10 Mbps.
MBP.
Okay, so
Okay,
if you take this one is faster.
yeah, yes, the Ethernet is faster.
Yes, Ethernet is faster. Fast
Okay,
Ethernet is 100 Mbps. Giga is 1 Gbps.
okay, okay,
Okay. So now we have to see here what I have written. The first one is you design your network. After designing the network, okay.
yes,
Second option is connect with the correct cables, and we connected with the correct
okay,
cables, and then define networks
okay,
for your devices. Yes, so I have defined network for the devices. Okay, and then you have
okay,
configured the interface IP address. So we are going to configure IP address, then we'll configure the routing, and then we'll test the communication. Okay, so for that we have to click
okay,
here for console access of the devices.
okay,
Router 1, router 2, router. So first we'll come to routers. Okay, see, if you will come to
yes,
router 2, router 3, you know, when you will boot first time router, okay, it will show you like this. Would you like
yes,
to enter in initial configuration dialog? So we'll say here no. Okay,
okay,
yes, and here also we'll come to R2, we'll say no. When we will come to
okay,
R3, we will say no. Okay, and
okay,
when you will see, when you will type no, see, R1 router, and see R2 router, and then it will come to R3 router. See, every router is coming like
yes,
router, right? So what we have to do
yes,
here, we have to come as we have to enable, and then we have to come here conf t, and we have to change the host name. Okay, host name R1.
yeah, host name,
Yes,
R1, yeah,
yes. So you have to change this all on all the routers. Enable conf t
yes, yes,
R2. Come
we have
here to,
host name as R2.
yes, to identify, because how you will know that this router is R1, this router is R2, R3, like
Yes,
that, right? Okay, so when we are
yes,
coming to R1, now we are configuring the R1 interface. So R1 have three interface: serial 2 by 0, E0 by 0, and E0 by 0. So we'll come here, we'll type here interface
yes,
serial 2 by 0 IP address 12.1.1.1,
yes,
then no shut. Okay, sorry, it's /8 I have
that's
used.
right.
Okay, okay. Wait, just okay. It is /8 slash,
That's slash 8, right?
yeah. Um,
Class A is slash 8, class B is slash 16, and class C is slash 24.
yes.
Okay,
Okay, no problem. According to this lab, it is /8, so
okay,
we will be using /8, not slash.
okay,
We'll type here interface serial 2 by 0 IP address 12.1.1.1 and 255.0.0.0.0. Okay, no shut, and then we'll come to interface E0/1 IP address 13.1.1.1 255.255.255.252 no shit. And then we are going to check Ethernet 0/0. So we'll type here, okay, uh, interface E0/0 and IP address is 192.168.10.10
Yeah, the standard.
no shut. Okay, and then you have to write here exit, or you should write end, whatever you like. You can come here and then you save it, WRITE, right, to save the configuration.
Right.
Yes,
Yes.
now you come to R2. R2 have two interface, so I'll come here, interface serial 2/0 IP address is 12.1.1.2 then no shut, then interface serial 3/0 IP address is 23.1.1.1.255.0.0.0.0 no shut, and then save. So you can write directly end to come here, and then you can write. Okay, so router 2 is completed. Now we are moving to router 3. So I'll come here,
Yes.
conf3.
That's right.
Yes, interface serial 3/0 I interface serial 3/0 IP address is 23 R2 serial 2 by
Yeah,
0.
and R3.
Okay, okay, we have to move to R3. R2 is already configured. Okay,
Yeah.
so this is
No, we
R3.
did R1 and R2. I
Yes,
think
yes.
yes.
Interface serial 3/0 IP address is 23.1.1.2. Okay, no shut. One second, I'm coming.
Yeah.
Someone is calling me. Okay, so we are on R3. Okay, R3
Yes.
conft okay, interface serial 3/0 IP address 23.1.1.2.255.0.0.0.0
Yes.
no shut, and then we'll come to interface E0/1 IP address is 13.1.1.1.2
Yes. 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 Yes.
252 no shut, then interface E0/0 IP address 192.168 dot
That's one.
no no
One. One or two.
10.100. Okay,
Okay. Okay. 10 or 100 is done.
yes, but okay, for okay, just for,
That's for the switch.
okay, no, for this lab, okay, let's
Yeah.
use
Yes. That's for the Ethernet to the switch.
no problem, 20.0. Okay, then it's okay here, 20.10. Okay, after that in the second lab I will use the same subnet. Okay, here IP is 10.1, sorry, 20.1, and here we are using 20.192.168.20.2.
Yeah. That 20. Okay. That's
So here we can use IP address 20.10. Subnet mask is 192. No, so all is configured here. Now save, and then we'll move to PC. So PC1 IP address is IP 192.168.10.1/26, and the gateway is 10.10. Save.
10. Yeah.
Here PC, if you will come to PC2 IP 192.168.10.2 slash
10.
26, and the gateway is 10.10.10.
6. Yeah.
PC3 IP is 192.168.20.1,
That's 20.
okay,
That's,
slash 26, and then 192.168.20.10 as a gateway. The router interface will be
no, it's 20. It's 20. No, in 3 is 20.
no 20.10.
Yeah, I'm talking about the PC3.
Yeah,
It's
PC3 is
20 dot. Yeah, put it
20.1.
like that. Yes.
Okay, so let's come here.
So I'm looking at it. The gateway is 192.1.2. So it's 20.10 also for the
Yeah,
gateway.
it's correct, no problem.
Okay, yeah, I've seen it. Okay, I've seen it. Yeah.
PC4 IP 192.168.20.2/26, and
20.
the gateway is 20.10.
Yeah.
All is done. Now if PC1 wants to
Yeah.
communicate to 192.168.20.1, no communication, destination host unreachable. Why? Because R1 router do not know about that destination network. If you check here, so IP route,
Yeah.
he don't know about that destination network. Okay, so how it will work on
Mm.
that? Okay, so now if you'll check that R1 do not know about 20 network, that's why R1 is not forwarding your packet towards that destination, right? So if
Okay.
you'll, so what you have to perform, you have to configure routing. So we have working with RIP routing, right? So you come here, type here conf t, type here router RIP.
Mm.
Okay, now how RIP is configured? RIP says that how many network is directly connected to you. So if you, okay, let's exit and type here, so IP route. Okay, so C means connected. Okay, C means connected. So how many directly connected networks you have?
1, 2, 3.
3. And L means link.
3. Yeah.
Link, this is IP address what you have
Link.
configured,
Okay.
okay, on those links.
Yes.
And this is a link name.
Yeah.
Okay.
Yeah. So that I can see the three connections.
Okay,
This direct is
so
connected.
yes, so you have to type here router RIP. Okay, then you say here network, same this one, the 12.1 12.1.1.0. if you will try like this, and the only connected networks, okay, network like this, then you have another one
Yeah.
13.1.1.0, and then again you have another one which is
Yeah.
192.168.10.0. Okay,
2.168.10.0.
and then exit. Okay, same configuration you have to configure on R2. Enable conf, or you type here so IP route. You have two network connected, so you write here conf t router RIP network. Okay, network is 12.1.1.0 network, NETW0. Okay, network 12.1.1.0, and then network 13 not 13 23.1.1.0, and then exit. Now come to router 3. So IP route three link connected, so you write here conf t router rip network. Okay, network is that you can say here 13.1.1.0. Another network you can say 192.168.20.0. Another network you have which is 23.111. Then exit. And now if you'll come here on R1 and if you'll type here so R1, okay, R1 so IP route, you will see that you are getting those routes, right? Those rip routes, right?
Yes. Yes. Yes.
And once you are receiving these routes in your routing table, and if you'll type this ping, see you are communicating.
Yes. Yes.
Okay, and
Yes.
now you will say okay which protocol is running on your router one. So if you'll type here so IP route, it's routing table, so IP protocol. Okay, here you will see that see RIP is running, right? RIP version 1 protocol is running.
Yes. 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 Yes.
Okay, and you have three network what you have summarized as what you have advertised. Okay,
Yes.
okay, now and they are communicating, no problem in the communication. Now you will say okay if RIP1 is sending message to RIP2, but how they are communicating. So if you type here RIP1, if you type here debug IP RIP, okay, just wait. In 30 seconds you will receive see sending version 1 update on 225.225 via ethernet 0, received version 1 update from neighbor, sending update on this is the broadcast address what they are communicating. Okay, now I told you that RIP communicate on port number 520, UDP port number 520. How we will come to know about that one? Okay, see here, right click here, start capture with the packet capture Wireshark, and you will see that UDP port
Yes.
number, yes, protocol.
No. No. Go ahead. Go ahead. Huh? Who? Ah. Okay. I never. Oh.
Okay, so now it is coming here. You can see that router 1 is sending update. Okay, a RIP. Okay, and if you'll check here, it is
Yes.
sending update on 225.225 RIP version 1, and you can see
Yes.
here that
There is. Yes.
user datagram protocol UDPs.
Yes.
Okay, 520.
Yes.
Okay,
Yes. Yes.
and
Port five
yeah, and
five
you
two
can see
zero.
here which protocol is running. Can you see here RIP routing information protocol? And if you'll open in deep, okay, you can see here
Yes.
RIP protocol version is 1. Okay, and this routing protocol is
Yes.
advertising three network 13 192.168.10.0, okay, and 20.0.
One.
Okay, you'll see in the deep message, okay, who is sending that IP address, who is sending this IP address. So each and every details you can verify in packet capture. Okay, okay,
Yes.
but now question will come that okay if everything is working fine, there is no any problem, then in which condition we need RIP version 2. Okay, Now, so if we want RIP
Yes.
version 2, where we can use RIP version 2? So if we are using this network, I hope you know
We are
about
using, we are here, we are using different classes here.
no, it's the same class.
No, no, are you talking about the communication? What I'm looking at, what I'm talking about is there are different classes of the classes are the routers are in different classes, network classes.
Yes, and they are communicating. There's no any problem in the communication.
Yeah, yeah, they are communicating well,
Yes, but I'm
and
saying
in
that
different networks. Yes,
yes
they are
now,
communicating well.
yes now I'm
Yes.
changing some IP address, okay, and you will
Okay.
see the problem.
Okay.
192.168.10.100. Okay. So now this is different subnet. This is different subnet if you know subnetting. Okay. In this subnet you have 64 users, and in
Okay.
this subnet you have 64 users. Okay.
Yes.
Now,
Yes.
so if I'm coming on R3 and I'm going to change my on all is to stop the debugging, and if I'm coming to R3 and I want to change the IP subnet pool, okay, so I'll come here and I will say instead of this IP address what we are using here, so IP interface brief exclude unassign. Okay, so here we are using uh, 20.10 IP address, but now we are changing those IP addresses. So we'll come here,
Yes. Yes.
interface E0 by 0, okay, IP address, okay, IP address 192.168.10.100, and the subnet mask we are using this as a 192. Okay, and you write here no shift. Now you type here exit. Only this changes what you need. Okay, now if you'll come to your PC3 also we have to change the segment. Here we have to say
Yes.
gateway is 10.100, and then IP address what you are using, it's 10.65 you are using on the PC,
Yes.
and on PC4 you are using
One time, sir.
66. Okay, and now if you are coming on router 3, first you say that okay conft and type here router rip. First you remove it and re-advertise. Okay, re-advertise the new network. So you say here router
Yes.
rip network. I want to advertise 23.11110. Then network 13
Yes.
192.168.10.0.
Yes.
Exit. Now if you are coming on R1,
Yes.
and now if you are checking your routing protocol table, okay, okay. Now tell me, do you have 20 this you have 10 network here, right? Okay,
Yes.
10.060 like this, right?
Yes.
Okay,
Yes.
and if you are coming on R3 here, so IP route, they are not exchanging. See, okay,
Yeah, that's
64.26 it is
64.
here, but they are not exchanging this 64 route. Okay, and one more thing I will tell you. If PC1 will try to communicate ping
10.
192.168.10.65, see destination host on reachable is not 20.65, it is,
Unreachable.
yeah, it is 10.65, 10.65, and this is 10.66.
Yeah.
PC address, see, 10.65, 10.66, and it is unreachable.
Yes.
And but if you'll come to R2 router, okay, enable
Yes.
show IP route, okay, okay, R2C. R2 is saying that if you want to reach 10
Yeah.
network, okay,
Yes.
so can you see here, have you advertised slash 24? You are advertising your network as slash 26, not as slash 24, right?
That's that. Yes.
Yes. And RIP1 do not understand this classless IP address. It understand all IP address as a class full IP address. So what is the default
Yes.
class subnet of class C? It is slash 24, right?
That's 24. Yes.
Yes. So RIP1 is saying that I will not understand this. I will understand this. So RIP is converting this one. Okay. So RIP is converting this
Yes.
one to this one. Now understand it. 10.0 slash
To
24.
24.
Okay. And from this side
Yes.
also, RIP1 is converting this as 10.0 slash 24. And this
24.
is
Yes.
coming here. Okay. Now
Yes.
understand
Yes.
carefully. Okay. So what I wanted to say. Okay, let me
Yes.
take the snapshot of this one, then I'll explain you. Okay, now see, RIP1 is sending this update, but RIP is converting this one to this class full, this classless IP to
Yes.
class full.
Yes.
Okay,
Yes. Yes.
okay. Now again, same here. It is coming. The update is coming like this. RIP is update changing this
Yes.
classless IP to classful IP, and it is keeping in the routing table. So router is saying that I'm receiving two same network from R3
Yes.
and R1. So you can check here routing
Yes.
table. See, it's saying that I'm receiving this two network from two different neighbor. Okay, and this is not a correct statement
Yes. Yes.
because both neighbor is sending you
Yes.
different subnet, right? Now, so R2 is
Yes.
saying that I will do load balancing. Okay, now tell me, if you will
Okay.
ping, if you
Yes.
will ping 10.64, maybe if you are, some user is connected here, and if that user will ping to 10.65, okay, if
Yes.
that user will ping
Yes.
10.65, so this R2, what this R2 is doing, R2 will say that okay, let me do load balancing, so I will send one packet this side and one packet this side. Okay,
Okay.
okay, so this one packet will communicate and one packet will drop because
Yes.
65 is not this side.
I drop on the other side.
Yeah, so one packet
Yes.
is okay, one packet drop, one packet okay, one packet drop, okay drop, okay drop. So your network communication will not constant.
Yes. Very consistent. Yes.
Yes, inconsistent. So now if you have one another user here, and if that user is trying to ping 10.1 PC, so it will say no, I am receiving 10.0 network from two different IS neighbor here. So here also it will do load balancing. So one packet okay, one packet drop, one packet okay, one packet drop. Okay,
Yes.
now but you will say no, I don't want like this, these configuration. Okay, because see, you cannot configure
Yes.
classful IP address every time, because in the network you will see every time classless IP address. So if you have classless IP address, you will look for protocol who support classless IP. Okay, that's why we need RIP2. Now see, if we will configure RIP, see, if PC1 is trying to communicate here, problem, right? But if you will come here and come to all routers, and you say instead of RIP1, what you say, you convert it router RIP, just one command, version 2. Okay, and all commands is already there, right? Okay, but if you want, we
Yes.
can we can rewrite again. Okay, see how to configure RIP2, router RIP version 2, and connected networks, network what, 12.1.1.0, then network 13, and then we have to write like this: 192.168.10.0. Okay, and then here you have to write here no auto summary. Okay, no auto summary means please do not summarize my network.
Okay.
Okay, this one, remember,
Yes, yes, no auto summary.
it was summarizing this to 24. He's saying that please do not
Yes.
summarize, please keep it as 26.
To leave it in 26.
Yeah,
Yes.
here it is also saying that please keep it as 26, please do not make it as a default summary. Okay, because if
Okay.
you will see
Yeah.
here, see, if you'll see here, and let me show you, if you'll write so IP protocol, one command, mm, so IP protocol, I can show you some, it is written somewhere that default summary is, where is that? Okay, see, can you see here, automatic network summarization is in effect.
Yes.
That's why rip1 do the
Yeah. Auto
summarization.
summary. Yes.
Yes. Okay, but if that's why you have to write here this command, no auto summary means please do not
No auto
summarize my
summary.
network. Yes. Okay, and then next come to r2. Okay, r2 also same thing, you have to type here router rip version 2 network you say that okay, I have 12.1.1.0 network 12.1.1.0, and then again I have another network which is 23.1.1.1.0, and then no auto summary.
Yeah.
Okay, now you come to r3 router, same here also, router rip version 2 and network. Okay, you can say that okay, I have three network, 192.168.10 dot, it is not 0, it is 10.64. Now you have to advertise like this. Okay,
Yes. Yes.
then I have another network which is 13.00, then again I have one other network which is 23rd, like this, then you write here no auto summary, and now you see what will happen. Now if you are coming on r1 and typing here so IP route, can you see here, now you are receiving this 64 as a rip, can you see here,
Yes.
and on
Yes.
r2,
Yes.
yes, now on r2 if you'll come here, see, now on r2, now it is not load balancing. See, 10.0 is separate, which is receiving from r1, and
Yeah.
10.64 which is
Yeah.
receiving from r3.
Yes. It's from our yeah.
Yes, and if you will
Yeah.
come here, and now if you'll try to communicate, see, communication is there.
Yes. That's communication.
Yes, and if you'll come on r1 and if you'll type here so IP protocol, now so IP protocol, it is rip version 2, can you see here? And now if you'll see here, see, automatic network summarization is
Not in effect.
not in effect. Okay, and now you are advertising three network. Okay, but automatic summarization is not there, so it is carrying subnet mask. Now I will explain you, see, in if in rip 1 what is happening, rip 1 say that
Mm.
how automatic summarization works. Rip 1 say that this rip router 1, when the router 1 is advertising this network, right? Okay, so it is like this 10.64, right?
Yes.
Okay, so when it will advertise, no, it will not advertise with subnet mask, it will advertise like this. Okay,
Yes. Yes. Yes.
yeah,
Yes.
so
Yes.
when router 2 is receiving this network, router 2 is saying that okay my friend, where is the subnet mask? So rip will say that I cannot advertise subnet mask, I only advertise network. So
Yes.
router 2 check that okay, this IP belongs to which class?
Three.
Class C.
which is 9192 is
Yes.
3.
So it will say,
Class
okay,
C, yes.
what is the subnet mask of class C? It's like this, right?
Yes, yes.
Yes. But what is happening in RIP2? RIP2 directly advertise like this with the subnet mask. So when it is coming, it's saying that okay,
Yes.
you are advertising like subnet mask. Okay, no problem. Okay. So RIP2 advertise the network with subnet mask.
Yes.
RIP1 do not advertise network with subnet mask. That's why router keep and add the default subnet mask with the network received by the neighbors, okay, in the routing table.
Yeah.
Okay, and let's run the debug command. Debug IP rip. Okay, see, rip is multicasting, okay, on 224009. I'll show you. See, 224009. Okay, so rip communicate with 224009. Multicasting
Yes.
means, yes. On all command is to stop the debugging. Okay. Now RIP has multiple options like what is the RIP timer. Okay, we have, if you want to know the uh, information in detail, so you have multiple show commands here. Okay, see here. So remember what is the use of this command, show
Hmm?
IP route.
Huh?
Okay, see, if you will write show IP route means you will receive the connected network plus received network, right, from neighbor. But if you want to filter, you write here show IP
Yeah.
route RIP, so you will get only RIP network. Okay, and these are the information
Yeah.
that okay, this is the network what you are receiving from your neighbor, this is the administrative distance, this is the metric, this is the from whom you are receiving from your neighbor, and this is the
Mm.
last update message sent to the neighbor, and this is the interface which is connected to my neighbor. Okay, now if you will write show IP protocol, show IP protocol, so IP protocol will show you that okay, which protocol is running on this router, what is the version of that protocol, how many network you are advertising from this protocol, and how many
Yeah.
neighbor you have. Okay, and these are some messages, hello messages, update message, flush messages, we'll know about this one. Okay, now if you want to know some detailed information according to your routes what you are receiving, so you can write like this also. So IP route, I want to know detail that who is sending me and how I am receiving 10.64, right, like this. Known via RIP means you are receiving this network from RIP, distance is 120, metric is 1. Okay, I am receiving this network from RIP, last update which I have received from my neighbor from on this interface from last 7 seconds ago. Okay, now this is my
Yeah.
neighbor, I'm receiving the information from my neighbor. Okay, and my neighbor is one hop away from me. Okay, there are some other information like so IP RIP database. Okay, so RIP also create one other routing table which is known as FIB. Okay, or you can say,
Ah.
yeah, routing information base, RIB. Okay, RIB and FIB is same, you can say RIB and FIB is same. Okay, forwarding information base and routing
Okay.
information base. Okay, so this is different, you know,
Mhm.
it is
Okay. Okay.
advanced level
Yeah.
when you will learn about CCNP and in that. Okay, say if you'll check here, so IP. Okay, see this information what you are receiving here. Okay, this information and this information is similar, but only the way of written is different. See, it's directly connected, okay, and auto summary is enabled there. Okay, who is my neighbor? Okay, so all the same information is there, but they just create two different table for faster conversation, like how fastly you can communicate with your neighbors. Okay,
Yeah.
okay, now let's come to know about rip timers. Like, okay, what are, how many types of rip timers is there? If I check here, so IP protocol, okay, so here you can see here rip have some timers. Is sending update in every 30 seconds, okay, next due 21
Yeah.
second, invalid timer 180 second, hold, flush, what is these things? Okay, so let's know about
Plus,
this.
yeah.
Okay, so rip use some
Okay.
kind of timer. Okay, so rip you use
Okay.
you can say for timer. Update timer means time between each update, means the update is sent to neighbor about the routing updates, like how frequently they exchange the route between neighbors, and that is
Yeah.
30 seconds. Invalid timer. Invalid timer means, like, invalid timer is known as margin of error of update, means if I
Yeah.
am not receiving this 30 seconds update from my neighbor,
Yeah.
okay, that how long
Mm.
I will be waiting for my neighbor saying that my neighbor
Yes.
is dead. Okay, okay, understood. So I will wait for
What is it?
180 second. Okay, and my neighbor, if I will not receive update from my neighbor, I will say that my neighbor is dead. So this is the neighbor, what
Yeah.
you can say,
Yeah.
neighbor adjacency
Ikaje?
timer. Okay, okay, and the third one is hold down timer. Okay, and hold down timer is what means, suppose my neighbor has given me one network, right, and after sending me first update, my neighbor is not sending me any update. Okay, so I waited for 180 second. After 180 second, I will declare that the network which I have received from my neighbor, okay, that network is unreachable. Okay, now, so once it is unreachable, I have to inform my other neighbors also. Are you understanding? Okay, so I will update to my other neighbors which is connected to me with destination unreachable with 16 hop away, like poison route update. So I will update my another neighbors that, okay, please, the network which I have received from my neighbor, that network is down. Okay, now when the network is, you have declared it is unreachable, that network will be there in your routing table. Okay, but and that network is down and it is not available now. So but how long you will be keeping in your routing table, because you have limited memory. So there is one timer which is known as flush timer. Okay, so your router will be waiting for 240 seconds, and after that 240 seconds your router will remove those routing updates which is there in its routing table, because routing table has the limited memory size, so it cannot keep all the routes, okay, all the unreachable routes, or you can say bad routes. Okay, and after 240 seconds it will flush from the routing table. Okay, but these timers are very long. Okay, these timers what we are talking here, these timers are very at least you have to wait for 3 minutes to be flushed, means to remove the network from your routing table. But in other routing protocol like EIGRP, OSPF, those are like faster. Okay, but if you want to make these timer faster, you have to, there are some timing changing how you can optimize the rip timers. Okay, so let's optimize the rip timers. Okay, so for rip timers, like see, it's 30 seconds, something like that. Okay, so if we want to change these things, we can easily change it. Okay, so we can come here to router 1, conf t, type here router rip timers basic. Okay, 5 hello, 10 invalid, 20 hold, 30 flush. Like this you change it and exit. And if you try to check, see, do show IP protocol. See, I have changed to this one. Hello is in every 5 seconds, and invalid is 10, hold is 20, plus is 30. So like to optimize the rip timers, you can optimize it. Now you will say no, 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 I want to. And okay, before that, the name, the timing what you have kept, okay, and here in the neighbor timing is different. See, so IP protocol, see here the timing is different. Okay, so for neighborship in rip, timing is not important. Okay, you can keep different timers. Okay, now if you'll say no, I want to make it default, very simple, come here router rip. Okay, and just say that no timer, timer basic. Just run this command, and if you'll check so IP protocol, see it comes to default. Okay. Now we have to work with rip passive interface. Now understand what is rip passive interface. Now see, this when this router is sending update to neighbor, right? So router 1 have how many neighbors? Okay, router 1 have 2 neighbor, R2 and R3. So router 1 can send RIP update via serial 2 by 0 and via Ethernet 0 by 0. Sorry, Ethernet 0 by 1. Not via Ethernet 0 by 0. Why? Because this side you have switch connected. Okay, so when you have switch connected, no need sending RIP updates towards this area, right? Okay, you can send RIP update to your neighbor which is a R2 R3, not your switch. But if you'll check here, if you'll run debug command here on R1, debug IP rip, let me show you something. When you will receive the update in a, you will see something that your router is generating message towards which interface. Okay, now sending, check the sending. Okay, now stop on off. RIP is sending version 2 update via 224009, no problem. Via Ethernet 0 by 1, no problem. Serial 2 by 0, no problem. But why your router is sending update towards your LAN, which is connected to switch? So unnecessary, in every 30 seconds, your router is sending some RIP message towards your LAN network. Okay, and your network bandwidth will be utilized due to RIP messages. So you say no, 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 this is wrong. So how we can stop this one? So that is known as passive interface. So what we can do, we can come simply here R1, and but you have to do only you can run these commands on only those routers which is connected to LAN switches, printers, like that. Okay, not like router to router, or okay. So you have to configure only in the end interface where it is connected with the end devices. Okay, so you can simply come here router rip. Okay, and you can write here passive interface E0 by 0. Here also come to router 3, enable conf t conf t router RIP, okay, passive interface E0 by 0. And now after that you run this debug command, debug IP RIP, debug IP RIP. Come here to R1 also, type here debug IP RIP and wait for the updates. Receive, okay, no problem. Check for sending towards ethernet 0 by 0, no problem. You will wait sending again with via ethernet, sorry, via serial 2 by 0, but no via C. Okay, see, sending serial 2 by 0, ethernet 0 by 0. Here also if you'll check here, sending update via serial 3 by 0 and serial ethernet 0 by 1, but no ethernet 0 by 0. So you have stopped sending RIP update towards your LAN, so you can optimize your bandwidth, right? Okay, now we have to work with RIP authentication. Okay, this is your final. Okay, so now understand RIP supports two type of authentication. Why we should use authentication? That like suppose if RIP1 wants to become a neighbor, so it's, see, if any hacker PC will also come, sorry, router will come, if that hacker will also run RIP, automatically it will become neighbor. So how you can stop and how you can secure neighborship, that okay, if you want to become neighbor, please put the same password what I am using, then you will become my neighbor. So here RIP is using two type of authentication, clear text and MD5. Clear text can be hacked, MD5 cannot be hacked, so we will verify both. Okay, so let me
Yes.
explain you again about this RIP authentication. That maybe
Mm.
when you have neighbors, right, two neighbor, okay, so normally what we do, whenever you
Yeah.
configure RIP here,
Yeah.
RIP here, automatically they will become neighbor, right? Okay,
Yes.
but when you have, like some
Yes.
kind of, your router is connected to, like multi segments with multiple neighbors. Okay, so is
Yeah.
maybe if there is some hacker router, if this hacker router will also
Yes.
configure RIP, right, this hacker will also become your neighbor, right? So how you can secure RIP update and RIP neighborship? So you can put password in the update, and if password will match, you will become neighbor. If no match, no neighbor. Okay, so here in RIP we use two type of
Mm. Yes.
password, one is clear text and one is MD5. So first I will show you with clear text, and we'll see that clear text is not
Yes.
recommended, then we will use secure one, MD5. Okay, so before that, what we can do here, we can right click and start wireshark and close this one. Okay, now we can come here to R1, on all, to stop updates. Simply what you have to do, you have to come here conf t, and then you write here key chain. You can write your name like Paul, Paul. Okay, you can say key 1, okay, and password is known as key string 123 at Paul, password string 123 at Paul. Password is defined. Okay, now you have to apply your password. So in which neighborship you want to apply? So here we have to apply authentication on interface. So I'll say that interface serial 2 by 0. okay, which is connecting to R2. I will say IP RIP authentication mode, put question mark. See, you have two, MD5 and text mode, so I will say text mode normal, okay. And then I will say IP RIP authentication key keychain, and the password what we have used, Paul. Remember, we have created one keychain as a Paul, so we have to use this one. And this is it is this one is case sensitive, okay, so you have to use same like that, okay? Case sensitive Paul. And after that, if you will see here, uh, we have to apply on R1, so I am applying on R3 from, okay, enable on, or no problem, let's come here on R1, conf t, I will say key chain Paul, key id 1, key string 123 at Paul, and then exit, then interface serial 2 by 0, ip 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 rip authentication, ip rip authentication mode is text, and then you say ip rip authentication keychain Paul, very simple. And now if you say here, just wait for few seconds, okay, R2 will stop neighborship. Even if you want to apply the same thing, you come here to interface E0 by E0 by 1, IP rip mode and authentication Paul. Just wait for few seconds, after that you will see that neighborship is down. And neighborship is down, and you will see that if you will open this clear text message, you will receive this response. Open this one, routing information protocol. See, authentication is simple, right? And see, can you see the password? You can see the password, right? That's why it is not recommended, this plain text password. And if you'll check here that, and if you'll come to R1 and check, see here, so IP route, see, route is there, but it will expire very soon, okay. It will wait for that 3 minutes, flush timer off. But if you want to refresh, you can refresh, clear IP route star, and then check routing table. See, no routes because your neighbor is down.
Mr. J,
Yes,
you were using WhatsApp right now.
yes, this wires are.
I think okay. I think I will learn to. I will have to know how to use that. Because I've never used it.
No problem, I will install this one in your system, okay, or you can install it, I
Yes,
will show
I
you
think
how
it
to
will be.
use
I
it.
will have it on my. Yes, I will install it. I will. I'll get the. I'll get it. I think I have the setup.
Yes, okay, and now,
Yeah, because you send it to me the other time. So I'll send it.
yes,
I will.
okay, so the recommended is MD5, okay, so how we should use MD5, okay. So let's see that, okay, how we can secure our
MD5. Okay.
updates, okay. So what we can do, I will say conf t
Yes.
interface E0 by 1 mode, I will change, see here, I will change to
Yes.
MD5, authentication keychain. See, keychain is already there, so only what?
Yes.
Okay, so only one command you can put here for update. Okay, so what we can say that let me, it is md5. Now again come to that interface serial 2 by 0, and same this command md5 mode. Okay, and text mode you have to remove from there. Okay, text, so you say that no text, only md5. Okay, and if you'll come here to that interface e0 by 1. Okay, and here also no text. Okay, only md5. Okay, and key string is already there, so no worry about
Yeah.
key string, because ip authentication key string, sorry, keychain with the poll what we have used here. Exit, same thing will come here to serial md5 mode, and this one poll. Exit, same thing you have to run there on your r2 neighbor if you want to become neighbor. So what you say, conf t interface serial 2 by 0 ip rip, sorry, before that we should create our password. Key chain poll key id 1 key string, we are using 123 at paul. Exit, exit, interface serial 2 by 0, I'll say ip rip authentication. Okay, mode md5, then ip rip authentication key chain, keychain I'm using Paul. Exit, now come here to r3 conf t, say here key chain Paul paul, sorry, keychain is paul. Okay, key id 1, key string is 123 at Paul. Exit, exit, then come here to interface e0 slash 1 ip rip authentication mode md5, and then ip rip authentication key is chain is Paul, and then everything is okay. And now you will see that they are receiving updates from neighbor. Neighbor is up, so ip route, see, neighborship is up now, routing updates are coming. And now if you will try to debug and check, okay, wireshark, if you'll run wireshark, see they are sending update, but if you'll try to read, see authentication is there, but you cannot read it. See, keyed message digest. Okay,
Yes.
okay, you are using md5, and see there is no
Yeah.
password, you cannot read. That's why. Okay, see, authentication data is there, authentication id, but no password. Okay, see, it
Yeah.
is in hashing mode, so you cannot read it. So it is recommended that
Yes. It's
you
a
should
password.
use,
Yes. You
yeah,
can.
you should use md5. Okay,
Okay.
so we are done with rip. Okay, tomorrow we will work with eigrp.
Yes. Okay.